Spontaneous combustion or spontaneous ignition is a type of combustion which occurs by self-heating, followed by thermal runaway and finally, ignition. Cause and ignition: a substance with a relatively low ignition temperature begins to release heat. This may occur in several ways, usually oxidation by a little moisture and air. Bacterial fermentation generates heat. The heat is unable to escape, and the temperature of the material rises. The temperature of the material rises above its ignition point. Combustion begins if sufficient oxidizer, such as oxygen, and fuel are present to maintain the reaction into thermal runaway. Affected materials, hay bales and compost piles may self-ignite because of heat produced by bacterial fermentation. Linseed oil in a partially confined space can oxidize, leading to a buildup of heat and thus ignition. Coal can ignite spontaneously when exposed to oxygen, which causes it to react and heat up when there is insufficient ventilation for cooling. Pyrite oxidation is often the cause of coal spontaneous ignition in old mine tailings. Pistachio nuts are highly flammable when stored in large quantities, and are prone to self-heating and spontaneous combustion. Large manure piles can spontaneously combust during conditions of extreme heat. Cotton and linen. When these materials come into contact with polyunsaturated vegetable oils, bacteria slowly decompose the materials, producing heat. If these materials are stored in a way so the heat cannot escape, the heat buildup increases the rate of decomposition and thus the rate of heat buildup increases. Once ignition temperature is reached, combustion occurs with oxidizers present. In addition, large areas of woodland, shrubland and grasslands during periods of the dry hot weather are known to be capable of spontaneously combusting, though the mechanisms causing this are poorly understood. This has been proven to occur via the life cycle of a variety of plants which require the area to be burned prior to germination. There have been unconfirmed anecdotal reports of people spontaneously combusting. This alleged phenomenon is not considered true spontaneous combustion, as supposed cases have been largely attributed to the wick effect, whereby an external source of fire ignites nearby flammable materials and human fat or other sources. Hay is one of the more studied materials in spontaneous combustion. As hay varies by the type of grass and location grown utilized in its preparation, it is very hard to establish a unified theory of what occurs in hay self-heating. It is anticipated that dangerous heating will occur in hay that contains more than 25% moisture content. The largest number of fires occurs within 2 to 6 weeks of storage, with the majority occurring at 4 to 5 weeks. The process may begin with microbiological activity, but at some point, the process has to become chemical. Microbiological activity will also limit the amount of oxygen available in the hay. Moisture appears to be quite important, no matter what process. At 100 degrees Celsius, wet hay absorbed twice the amount of oxygen of dry hay. There has been conjecture that the complex carbohydrates present in hay break down to simpler sugars, which are more readily oxidized. Charcoal, when freshly prepared, can self-heat and catch fire. This is separate from hot spots which may have developed from the preparation of charcoal. Charcoal that has been exposed to air for a period of 8 days is not considered to be hazardous. There are many factors involved, two being the type of wood and the temperature at which the charcoal was prepared. Coal, self-heating in coal has been extensively studied. The tendency to self-heating decreases with increasing rank of the coal. Lignite coals are more active than bituminous coals, which are more active than anthracite coals. Freshly mined coal consumes oxygen more rapidly than weathered coal, and freshly mined coal self-heats to a greater extent than weathered coal. The presence of water vapor may also be important, as the rate of heat generation accompanying the absorption of water in dry coal from saturated air can be an order of magnitude or more than the same amount of dry air. Oilseeds and oilseed products: moisture is a critical factor in self-heating of these materials. Typically, storage at 9–14% moisture is commonly satisfactory, but limits are established for each individual variety of oilseed. In the presence of excess moisture, but at levels below the required amount for germinating the seed, the activity of mold fungi is a likely candidate. This has been established for flax and sunflower seeds, as well as soybeans. Many of the oil seeds generate oils that are self-heating. Palm kernels, canola, and cottonseed have also been studied. References, notes. Bibliography, Babrowskas, Vitinas. Ignition Handbook. Boston, Society of Fire Protection Engineers. ISBN A978-0-9728111-3-2. Bose, P.C. Self-Heating, Evaluating and Controlling the Hazards, London, Department of the Environment, Building Research Establishment. ISBN 0-11-671364-X. External links, article on the spontaneous combustion of coal, spontaneous combustion demonstration.